In this video, we are going to learn about 3.3 electrolytic cell. At the end of this lesson, students should be able to state Faraday's first law of electrolysis, apply Faraday's law in calculation, and state the application of electrolysis in industry. Faraday's first law of electrolysis gives the relationship between the amount of material liberated at the electrode and the amount of electric energy that is passed through the electrolyte. It is defined as the amount or mass of any substance that is liberated at an electrode during electrolysis is directly proportional to the quantity of electricity in coulombs passed through the electrolyte. This means that any amount of substance produced at electrode is directly proportional to the amount of current used. The relationship is mass directly proportional to Q, where Q is the electric charge in coulombs C and M is the mass of substance liberated at an electrode. The quantity of electric charge Q is given by Q equal to IT, where Q is the electric charge in coulombs, I is the current in amperes, and T is time in seconds. The quantity of charge carried by 1 mole of electron is referred to as 1 Faraday. 1 Faraday is equal to 6.02 times 10 to the power of 23 times 1.602 times 10 to the power of negative 19, which equals to 96,500 coulomb. 1 Faraday is also equal to 1 mole electron. The greater the number of moles of electrons transferred, the greater the mass of the products. For example, the electrolysis of sodium iodide to find out Faraday can be given as follows: the equation for reduction, the equation for oxidation, and the overall equation. From the equation, 2 Faradays is equal to 2 mole of sodium metal, and from the oxidation reaction, 2 Faraday is equal to 1 mole of iodine. So, we can say that 2 Faraday of charge will give 2 moles of sodium metal and 1 mole of iodine. So, the number of electrons reflect the number of Faradays. In order to apply Faraday's law in a calculation, we need 3 things, which are balanced half reaction related, Faraday constants, 1 Faraday equal to 96,500 C per mole electron, and the third one is the formula Q equal to IT. To further understand this, you should keep in mind to solve the problems based on what is being asked. For example, how much calcium will be produced in an electrolytic cell of molten CaCl2 if a current of 0.452 ampere is passed through the cell for 1.5 hours. In this electrolytic cell, the half-cell reactions and overall cells reactions are as follows. But if you read the question properly, the question asks for calcium only. So, in this question, we do not need to pay attention at anode or overall cell equation because we will only focus on what was being asked, which is the half cell at cathode, the equation for Ca only. For example, a constant current of 23.5 ampere is passed through an electrolytic cell containing an aqueous solution of NaCl for 1 hour. Calculate the volume of chlorine gas and hydrogen gas produced at STP and determine the mass of NaOH formed. To solve this question, we must first identify which half cell is involved in the calculation. The clue is hydrogen gas is produced. This means that water is selected at cathode because only water can produce hydrogen gas in this electrolytic cell. So, we will focus on the equation at cathode for water, which is 4H2O plus 4 electron produce 2 hydrogen gas plus 4 OH minus. From this equation, we can see that there is 4 mole electron equivalent to 4 Faradays and equivalent to 2 mole hydrogen. We can simplify this relationship into 2 mole electron equivalent to 2 Faraday and 1 mole hydrogen gas. Next, by using the formula Q equal to IT, we will get the value for electric charge, which is 84,600 coulomb. To solve this question, first we write down the relationship between 2 Faraday and 1 mole hydrogen gas. 2 Faraday means there is 96,500 coulomb. But in this electrolytic cell, we only have 84,600 coulomb. So, to find out how much mole hydrogen gas is, we will do the stoichiometric calculation. 84,600 coulomb times 1 divided by 2 Faraday. And we will get the answer 0.4383 mole hydrogen gas. To convert the mole into volume at STP, we multiply the number of moles with 22.4 and we will get the answer 9.82 liter. Next, we want to find out how much volume of Cl2. So, by referring to the equation given, 1 mole hydrogen is equivalent to 1 mole chlorine gas. So, 0.4383 mole hydrogen is equal to 0.4383 mole chlorine. To find out the volume of chlorine, again, we times the number of moles with 22.4. And we will get the volume for chlorine as 9.82 liter. Last, we want to find out the mass of NaOH. From the equation given, 1 mole of hydrogen gas is equivalent to 2 mole NaOH. Hence, 0.4383 mole hydrogen gas is equal to 0.8766 mole NaOH, we convert the number of moles into mass by multiplying with molar mass, which is 40, and we will get the mass as 35.1 gram. Next example, what weight in grams of copper will be plated out from a solution of Cu2 plus on passing 0.15 Faradays? Given the equation, Cu2 plus 2 electron produce copper. From this equation, 2 Faraday is equivalent to 2 mole electron, which is equivalent to 1 mole copper. Given that we have 0.15 Faraday, which means we can do stoichiometric calculation to find out the number of moles of copper. 0.15 times 1 divided by 2, and we will get 0.075 mole copper. Hence, we can convert the number of moles into mass by multiplying with the molar mass 63.6, and we will get 4.77 gram mass of copper. Last but not least, for application of electrolysis in industry, you can check this out in your lecture notes. That's all for this video. Thank you.